I'm going to talk about the results of a study in which we compared horizontal and vertical dynamic people navigation. And with this work, we contribute a recommendation on when to use which of the two orientations. But before I'm going to talk about the actual study and the results, let me just briefly clarify the term dynamic people navigation. So how does the technique work? Dynamic people navigation, a spatially aware display, such as the tablet here, serves as a peephole to a large information space, like a map, for instance. And the user physically moves the peephole to off-screen content as if it were situated in physical space. Now, the concept of dynamic people navigation is not new, or there's no novelty today. And a lot of aspects and properties of people navigation have already been investigated, such as, for instance, the effect of the peephole size on user performance. But what has not been investigated yet is the effect of the orientation of the peephole canvas on user performance. And yeah, some scenarios come with requirements that already determine whether to use a horizontal or a vertical peephole. But others do not, and then it's up to the designer whether to use either of them, and this was exactly our starting point. So the motivation or research question was behind that study was what effect does canvas orientation have on user performance? To answer the question, we conducted a study with 16 participants. And in this talk, I will only focus on the actual task, which consisted of a search task and a reconstruction task. Please note that there was something in between the two, so participants wouldn't just do the search task and immediately start with the reconstruction task. So there was some time frame between. Okay, in the search task, participants had to find a series of specified targets, target symbols on the canvas. And as a peephole device, participants used the Microsoft Surface 2 tablet, which was tracked by 24 OptiTrack cameras. On each canvas, we placed 8 target symbols and 12 distractor symbols. So there were 20 symbols on each canvas. And yeah, this is a screen capture of the tablet view with the target symbol to be found in the center. And as soon as the indicated symbol is found on the canvas and centered on the screen, a new target symbol to be found appears in the center of the screen again. So each participant had to find a series of 8 target symbols 8 times, resulting in 64 samples in sum per participant. And we recorded the path length and the navigation time between 2 correctly selected targets, subsequent consecutive targets. In the reconstruction task, participants had to reconstruct the locations of the target symbols. And reconstruction was done on the same, but this time plain canvas. So if they just finished or if they had done the vertical orientation before, then they would do the reconstruction task also on the vertical canvas. And this is again the tablet view, and with the target symbols, the 8 target symbols on the right and the left border, and each symbol could be dropped on its presumed location on the canvas by touching it. So there was no time pressure. Participants could take as much time as they wanted, and if they felt like I want to drop this target somewhere else, then they could just re-drop it somewhere else, and the old location was deleted. So actually pretty comfortable. So what did the results show? In terms of spatial memory, navigation time, and path length, there were no significant differences. So there were, however, significant differences in terms of workload. Sorry. In the vertical orientation, the physical demand was higher than in the horizontal orientation. Now, that was not so much of a surprise given the ergonomic conditions. I mean, participants had to hold the tablet in the air and had to move it steadily. So, but there was another significant difference in workload, and that is in horizontal orientation, the mental demand was higher than in the vertical orientation, which was a bit unexpected. So, what could be the reason for that? The first thing we did, we analyzed our observation notes and the video recordings. And we realized that during navigation, most participants didn't turn around when getting familiar with the canvas. They were always gazing into one direction. And this means that even though they had more degrees of freedom, that is the rotation around their own axis, they wouldn't use it. They just avoided it at the beginning. And when asked about that, participants stated that, or they reported a lack of initial orientation in the horizontal condition. And that it had been easier to establish a mental map of the canvas when they avoided turning around at the beginning. So these are just some example quotes from the participants. And therefore, we assume that the extra degree of freedom in the horizontal condition might have caused the increased mental demand. However, this is only speculation, and this should be subject to further work, or future work. So what can we conclude? Unless requirements do not already determine the orientation, use a vertical orientation for short-term activities, use a horizontal orientation for long-term activities. And of course, you can use them complementary. And finally, supporting the establishment of a mental map is crucial, in particular for the horizontal condition. So with this, I want to end my talk, and I'm happy to take your comments and questions now.
Hi Jens, this is Jens from Graz University of Technology. Nice topic, a nice investigation. I have two questions. How did you determine the size of the information space that you were moving in? Because you used quite a large area to move, and it has been shown that the performance also depends on that physical information size. And the second one, how did you, which kind of mapping of your movement to the information space did you use? So was it a linear mapping, or did you have some kind of curved mapping? So can you give me a little bit more details about that?
Yeah, sure. Thanks for the question. We took a canvas, or the canvas dimension were motivated by prior study, where we took two cube projectors with a dimension of almost 3 meters by 80 centimeters. So that was basically the motivation. And this was the physical dimensions of the canvases. But you're right, of course, if we had taken another canvas dimension, another proportion, or another canvas size, or whatsoever, the results may have eventually look a bit different. And the second question, we took a linear, how did you call it?
Like a linear mapping, so you moved your device linearly, so and it mapped linearly to the
it was just a plain flat linear canvas.
Okay. For any particular reason, or
actually, that work was motivated by the idea that spatial tasks could be quite interesting, and to have a kind of a real-world mapping like you have on map navigation. So this is the only reason. But of course, I mean, there are certainly different scenarios that may require a curved Peephole canvas. So that could certainly also be subject to future research.
Okay, thank you.
You're welcome. Thank you.